Hi everyone, and happy International Women in Data Science Day, which is the 7th of March everywhere, which means Australia gets a head start on that today on Monday. So thanks for joining the Women in Data Science at the Australian Data Science Network panel on raising the bar for Australian data science. So as you can see here in Brisbane, our university campuses are closed. We've got many people coming to you from our homes as a result, and our thoughts are absolutely with everyone impacted by the floods. I'd like to start by acknowledging our traditional owners. Here in Brisbane, I'm on the unceded lands of the Turrbal and Yarraga people, but I'd absolutely like to acknowledge all of the First Nations people across Australia, where we're all coming to you from and where we all work on data science. I'd pay respect to their elders' laws, customs, and creation spirits, and recognise that these lands have always been places of teaching, research, and learning. And in particular, our First Nations people across Australia, of course, were our first scientists, our first data scientists, and our first visualisers. So I'm Dr Kate Helmstedt, Senior Lecturer and ARC DECRA Fellow at QUT. I'm a Women in Data Science Ambassador for 2022, and I'm really pleased to be facilitating this discussion with 5 of Australia's top data scientists who also happen to be women and fantastic role models. Today, we're going to be talking across a broad range of ways that we can raise the bar and that we are raising the bar in Australian data science, from what we are as a field to who we are as a field and what we want to do as a field. So first of all, I'll introduce Professor Flora Salim, who is set to start an exciting new role as the inaugural Cisco Chair in Digital Transport and Professor at the UNSW Centre for Critical Digital Infrastructure. Until very recently, she was at RMIT in Melbourne for 13 years as a professor at the RMIT School of Computing Technologies and the co-deputy director of RMIT's Centre for Information Discovery and Data Analytics. So Flora, thanks for joining us, first of all. When you look back kind of 15 or 20 years, could you ever have imagined ending up in this emerging field of data science? And was there an event that really got you kind of headed in this direction?
That's a really great question to start with. Well, first, I need to say that I'm always fascinated with patterns since I was a child. My parent told me that I always try to find patterns in the things that I observe. So I think I got into data science even before it was called data science. So when I actually did my honors and my PhD in computer science at Monash, I was focusing on applying machine learning and stream data mining. I've always been fascinated because I like observing the world. I like to capture data with sensors, but we didn't have much data back then. So we had to start simulating data, generate data from heuristics and small observations. But then not long after I finished my PhD in 2009, I found that we're actually entering that data deluge, the age when we actually have lots of data, and explosion of Industry 4.0 helped that, and also the acceleration of machine learning, deep learning, into being able to generalize a lot of patterns from observation. So actually, it becomes like, you just have to ride the wave. And I think my childhood fantasy of working with things that I could observe and, discover new patterns become a reality. So it's not really, a turning point really, but, it's been a fascination.
Beautiful. Thanks, Flora. Up next, we've got Professor Joanna Batstone, who spent 3 decades with IBM in Europe, Australia, and the United States, where she held a variety of technical and business leadership roles in IBM's research and development laboratories, including work with IBM, Watson, Data, and AI. In 2020, she returned to Australia, luckily for us, to become the inaugural director of the Monash Data Futures Institute at Monash University. What about you, Joanna? First of all, thanks for joining us. So had you always imagined you'd end up in this emerging field of data science, and did something nudge you in this direction?
Thanks, Kate, and it's great to join all of you here today for this discussion. So a little bit like Flora, the discussion around data for me started very early. I was trained as an experimental physicist, and this was actually at a time where the data that we would collect from our lab instruments was often paper graphs, printouts from spectrometers, digital images from electron microscopes that were on film and not digital. And so my experience with data started really as an experimental physicist trying to understand how to interpret data sets from your experiments. But I would say the turning point for me was probably, and obviously this dates me a bit, but the turning point for me was in the mid-1990s when the internet boom really struck. The whole .com era really struck. We had internet browsers easily available, and it fundamentally, those mid-1990s fundamentally transformed the way that we think about access to data, access to information, and it transformed business. And so being in the corporate world of a large technology company, suddenly the massive amounts of data that were being generated as everything went digital, lab equipment went digital, photographs went digital, social media went crazy. Suddenly we're in this massive exploding world of data. And so that for me was really the tipping point, that we needed to understand how do we leverage and build new techniques to analyze data. And so it's interesting always for me to hear data science described as an emerging discipline, when it feels like we've been doing science on data for decades and decades.
So true. And it's great to think about kind of the legacy of the field that we're, really trying to build still at the moment in Australia. Thanks, Joanna. Up next, we have Associate Professor Jessica Kaza, who's also at Monash University, where she's an Associate Professor in the School of Public Health and Preventive Medicine. Her research interests are in biostatistics, data science, broadly defined. In 2020, she took on a major leadership role, becoming the President of the Statistical Society of Australia. Welcome, Jess. Thanks for joining us. What about you? Had you always thought you might be a data scientist? Did something nudge you in this direction?
Thanks, Kate, and thanks for assembling such a wonderful panel. Look, if I look back far enough, I was never going to be a statistician or a data scientist. I was going to be a lawyer. I started a law degree. I'd always enjoyed maths and statistics in high school, but law was what I was going to be. Very quickly, I realized my personality was not suited to that. So I kept up with my maths and finished my maths and stats and did a PhD in statistics. And I suppose, I never really, it's taken a bit of time for me to label myself as a data scientist. I've always thought of myself as a statistician, and more specifically a biostatistician. But looking at what I do day to day, I work with data, I help people to understand their data, I help people to plan experiments so that they can answer questions using data. Nothing that I do is really not data science. And thinking about statistics more broadly, I suppose, picking up on something that Joanna said about being surprised that data science is labelled as an emerging discipline. Well, I suppose statistics has always been to do with data, hasn't it? It's always been the science of data, you could say. So I suppose for me, it's been a gradual realization that not only can I label myself a statistician, I'm also a data scientist.
Good to come to terms with it, Jess. Next, I'd like to introduce Professor Sally Cripps, who was an Australian Research Council Future Fellow from 2014 to 2018. She was most recently a Professor of Statistics at the University of Sydney and was Director of the ARC Training Centre in Data Analytics for Resources and Environments, or DARE for short. Last year, though, she moved over to CSIRO and Data 61, where she's now the Research Director for the Analytics and Decision Sciences Group in an exciting role over there. Welcome, Sally. What about you? Did something nudge you towards this field?
Yes, well, thank you, Kate, and thank you for inviting me here. And it's great to see all these wonderful women here talking. For me, the journey started, I suppose, in my PhD when I did a PhD in statistical methodology. So it was very much a love of mathematics and not of data that initially got me into this area. And my initial career was spent in maths and stats schools. Then I moved across to business schools, where it was clear that the business world was taking data far more seriously than the academic world. And I got into sort of thinking how we might, it seemed to me that we were not using all this wonderful information that was flowing out, and how might we use that for better insights. but it wasn't really until I got my future fellowship that I decided to, take a walk on the wild side and be applied, as opposed to writing statistical methodology papers. And that was a great move. As a Bayesian statistician, we have very many flexible models. And so it was the idea about, well, how can I put what I know together with data that's around there to try and solve some really grand challenges, to try and do some data for good. And that led me to, initially led me to be part of a COE bid, which got down to the last 10, but didn't get up. And then that formed the basis for their ARC centre that I eventually got up. And primarily the concern there is, how do people make decisions under difficult circumstances, actually not with huge amounts of data, because a lot of the time when we're making decisions around our environment, we're making it with very little data. So how can we use the data that we have together with expert knowledge to try and make better decision for a better society for Australia going forward? So that for me is data science. Yeah.
Beautiful. Thanks, Ellie. And we've seen some of that, I guess, in action with people's responses to the floods recently as well. So that's very interesting. Thank you. And last but not least, because if she's least, then I'd be fired. But we've got Professor Kerry Mengerson, who's a Distinguished Professor of Statistics at QUT and Director for the QUT Centre of Data Science. In 2016, she became the first woman to be awarded the Pittman Medal, the highest honour presented by the Statistical Society of Australia. Kerry is an Australian Laureate Fellow and one of only a very few people who are Fellows of both the Australian Academy of Science and the Academy of Social Sciences in Australia. Very impressive. Welcome, Kerry. What about you? Have you always thought of yourself as a data scientist, been a data scientist, or did something nudge you in this direction?
Yeah, thanks, Kate. Well, I think it's hard to have imagined being a data scientist when data science wasn't really a thing. But certainly the different domains of what we've done have really converged to this area of data science. And so data science now is this amalgam of different domain areas and different disciplines. And so we have people from statistics and computer science and information sciences and all the different applied domains who have an interest in data, all coming together under this banner of data science. So I realised in my undergraduate degree, which was in mathematics and computing with a large swathe of statistics in it, that there was this opportunity to bring together mathematics, statistics, and then this really emerging field at the time, such exciting field of computer science. And then one time at QUT, about 10 years ago now, I was in the corridor and I was in statistics. So this is my silo of statistics, my office. And beside me was a professor of applied mathematics. And opposite me was a professor of machine learning. And we would go into the corridor and talk about problems that we were looking at. And they were all the same kind of problems, but we're coming at it from the different perspectives of our disciplines. And so we thought, really, it's time to get rid of those barriers and really start to think about the area of statistics, machine learning and computer science together. And that then really initiated or developed into the Centre of Excellence that we had, or ASINS, for the Mathematical and Statistical Frontiers. What's happened since then in the time period has really been the understanding that it's not just math, stats and computer science or machine learning, but it's really much broader. It's math, stats, computer science and machine learning and AI and all of the things that are around data. And so I think this term of data science is really something that we're all stepping into under this umbrella, noting, as Jess said, that we have our own sort of strengths in that area and our own discipline hats, if you like, but we all throw our hats into the ring when we come into this field of data science.
Wonderful. Thanks, Kerry. And thank you all for joining me today in this discussion. I'll just flag for the audience that there is a Q&A box down the bottom. So shoot your questions on any topic into that Q&A box, and we'll hopefully get to some of those at the end. But for now, I'd like to, with the panel, kind of delve more into this question of what are we as a field? And we've already said that There's a long legacy here, but there's been a lot of discussion recently. Is data science a field in the same way that biology is a field? And if it is, do we gain from it? Like, how do we benefit from describing ourselves as a field if that's what we want to do? What about, first of all, we hear from Joanna on this?
Thanks, Kate. So I started by saying, is data science really an emerging field, or is it something that's been around for a long time? And I think there is this debate around, as Jess and Kerry mentioned, right, are all statisticians by default data scientists? What about a physicist? Does a physicist become a data scientist? And so I think this notion of really trying to understand or drive new insights from the data to solve, in many cases, real world problems is really the application of experimental and numerical techniques, but now to solve real world problems. And so as I think about the role of the data scientist today, it's very much around taking our toolkit of techniques and applying them to go after biostatistics, as Jess was describing, or perhaps a financial analysis or a environmental analysis of the data set, but bringing the tools and techniques together. So this notion of data scientist, I think it's very important to grasp. And I think it's very important as we think about educators to help students understand the opportunities associated with the role of a data scientist. And it's not just about a tool or a technique, and it's really about bringing those insights to the data.
What about you, Sally? What do you think? Is it worth doing, describing ourselves as a field, and how do we do it if Joanna's right there?
So I think, so I'd like to agree with Joanna and then maybe add a couple of other insights. So I think data science, that is the idea of using data to understand the world around us, make better decisions, has been actually around for a couple of thousand years, really, so people have been measuring, trying to figure out what the Earth's circumference is based on small measurements. So that has making inference about big things from just local things. So I think that has been around for a long time. I think what's really interesting here is two things. Firstly, it's the coming together of a number of other disciplines. When I'm saying disciplines now, I'm talking about university disciplines, because in a sense, they're all part of the one discipline. So coming together to solve not just problems to do with maths and stats and computation, but the typical thing is to have an application. And to me, that's the exciting bit, is the application along with the data science, because what I've learned is that actually new techniques developed in so-called data science are actually inspired by solving something specific. So you start with a specific problem and then you learn to generalize. And what you learn from that specific problem often is that there's no one solution that either statistics, machine learning, or computer science has got, but together you might solve something really great. I think that, but going forward, I really feel that the big challenge for us now is, how to operationalize this, how to do with this at scale. And so in the same way that, you needed to learn about electricity before you could have electrical engineers, I think that's what we're seeing here with data science. I think you need all the science bits, and we're putting together the science bits, but ultimately, I'm going to say something that's against my own self-interest, but ultimately, I think it's an engineering discipline that is going to actually see this leveraged at scale based on the stuff that we're doing. And that's how I see it going forward as a field. Yeah.
Fascinating. And okay, what about Jess, from your perspective, what about someone who was maybe a bit hesitant to describe themselves as a data scientist at first? Do you agree with these guys?
Look, I think it's very interesting to think of data science as kind of an engineering discipline in a way. I'm not sure I'm not sure I disagree with that. I feel that data science, what's been coming across here is that it's very much an enabling discipline. It's something that we do in order to answer questions. It's something that we do. We apply all of the tools that we have from statistics, from computing, from the information sciences in order to gain some insight into the world around us. And look, I think back, I did describe some sort of hesitancy in describing myself as a data scientist. And I think part of that, and what Sally said when she introduced herself and she discussed this really rang true for me, is that she one day opened her eyes to the applications and realized what was going on there. And that was very much the same for me. I realized that, I had some dreams at one point of being a heavy duty theoretical statistician. And then, much like being a lawyer, I realized that wasn't exactly for me, and my strengths lay elsewhere. My strengths lay in applying statistics to answer questions, to look at the data, to think about the data scientifically. Yeah.
Interesting. So you're kind of erring on the side of maybe it's the fact that it's quite applied and really applied to data and applied questions that makes it specifically data science.
Well, I'm not sure I necessarily agree with that entirely, because I do feel that there is research that goes on in data science. Of course there is, like learning how to do things in a better way, learning how to answer questions that we haven't been able to answer before. Yeah, I suppose I feel though that whenever we do answer these questions, we do need to bring in a deep understanding of the field in which we're applying these techniques to. You can't just jump into a field and decide, get a data set and mess around with it. Doing that can be very, very dangerous, and you can end up making some very strange, drawing some very strange conclusions. So I think data science, it needs to have as part of it a deep understanding of the subject matter, a deep understanding of causal mechanisms too.
Thanks, Jess. And Kerry, what about you? So is data science an engineering discipline? Is it very deeply rooted in the application? Does it need to be a field? I know that you think of data science as being very kind of all encompassing, and if you're touching data, maybe you can call yourself a data scientist. What do you think?
Yeah, I think it's when we set up when we convened, and everybody's part of this, the Australian Data Science Network, and we were looking to create that, and looking around the country at the different research centres in data science. There's such a range of different focal areas and different schools even that are directing data science centres. So there's from the business, engineering, health, mathematical sciences. There's all of these different disciplines that are leading the area of data science and leading our research centres in data science. And I think one of the benefits of the Australian Data Science Network is to bring together those different perspectives so that we do create this broader perspective of data science. And I think it is about extracting knowledge from data, but it can also be, so we have a very strong applied arm to this, and this has been discussed. But I'd also like to argue that there's a very strong methods and computational and theoretical arm in data science as well. And so the main thing is that people, we talk to each other, so that we create this pipeline between, you might have somebody who's very strongly theoretical, but they then can talk to the people in the methods, who can talk to the people in the algorithms, who can then talk to the people in the applied area, and then that gets all funneled back. So there's a challenge, a thorny challenge in the application area that gets funneled back through the system. And so it becomes this this network or this pipeline of different disciplines working to answer the applied problems. But in doing so, then there are, or I don't even mean the applied problems, working to extract knowledge from data. And often that's through the applied problems. But there is this strong theoretical and methodological aim and element to data science.
Brilliant, thank you. And I think that this conversation kind of pushes us nicely into our next topic, which is moving on from what are we as a field to kind of who are we as a field? Like if we're a network of scientists and a network of data scientists, we need to think about what needs to change to raise the bar on who we are? And I'll open that, I suppose, by saying, how do you guys think that data science is going when it comes to making sure that women are properly represented in this network that we're building? And I'll start with you, Flora.
So before I jump into the later part of the question, let me just tie my answer to the first part of the question that I answered before. Coming from computer science field, I think as well as, you know, I've been publishing also in the community of data mining community, and which actually at the moment, there's no hesitation that we call ourselves as data science. So even, for example, a conference that we publish in, for example, a KDD, has called themselves as the premier conference in data science, no longer knowledge discovery and data mining, because it's quite a mouthful text, but data mining. But I actually completely agree with everyone before that, who we are as a field. Well, we are really interdisciplinary at the moment, because the contributions, because the amalgamation of the different fields from computer science that brings in things like, you know, the algorithms, you know, the sorting, the search algorithms, the graph algorithms, to the mathematics and the statisticians, to actually providing the fundamentals of how to understand data, and you know, the Bayesian and statistical methods of that, for example, and including industry actually contributing actively to data science, like from the database technology that has actually evolved so far right now, that can actually be, you know, before you had to use structured data for everything, but now you have NoSQL, and you got a lot of ways of storing big data. And so actually data science itself is very interdisciplinary field, but also brings in both research and industry together. And I think we have to acknowledge that. But what I found really fascinating is the data science now in Australian field of research is actually named data science. So it's a new for code, but it is put under information and computer science. So I mean, you know, we can have an argument whether that's a right placement or not, or it should be on its own, you know, 4-digit 4 code. I mean, 2-digit 4 code, if we want to make it really interdisciplinary. But I think as data science, it is a field, and I think we really have to think about it as a field. I mean, because like it'll be much nicer if, let's say, we talk about, you know, I do times I'm doing data science, but particularly more on data science in time series and spatial temporal data. But my approach is a lot of them are using modeling with machine learning and deep learning techniques, and it will be very different to other people in the call who might be doing something differently with time series and spatial temporal data, for example. And we need to bring in absolute domain experts, right? So and we have to have diverse opinions or voices in order to better understand and not actually reinventing the wheel. Because sometimes we think we are the technical experts, but actually there are better ways of doing it because the domain experts have been dealing with this type of data for ages. So things like, for example, thinking about, let's say, the astronomers or geographers have been working with cartography, astronomical charts and stuff like that, right? For hundreds of years. And when we're thinking about spatial temporal data coming from space, can we actually borrow some of the ideas from them? For example, just, you know, putting it out there. And yeah, in terms of women, I think we need to really incorporate them because they bring a completely different dimension to the discussion and different way of thinking about data, regardless whether they're very technical or whether they're coming from industry.
So Flora, would you say that the diversity in interdisciplinarity is it the same importance, do you think, in kind of thinking about gender and other kind of facets of diversity when we look at our field? So
I think alluding to a lot of statements in diversity and inclusion, you know, for example, even ACM ones, gender is an important aspect to it, but also there's a lot of other things like culture, because we have our own biases even when we capture data, when we actually analyze this data, and things like even where you are in your career. You know, if we want to be serious about diversity in data science, we absolutely have to include all of those different elements, not just gender. But obviously, we need to improve representation of women in data science.
Thanks, Flora. Jess?
I really want to thank Flora for what she's said there. I absolutely agree. I just want to extend on some of the points that she raised a little bit more. And one of those is on the concept of algorithmic fairness, for example. So a lot of applications of data science have, you know, developed these really rich, really interesting models that have ended up turning out to have things like unfairness and racism, all of these things baked in to the algorithm. And it's so important when we do data science to ensure that we do have this diversity of voices around the table, this diversity of cultural backgrounds, as Flora said, diversity of genders, all of these, looking at what we're doing, thinking about what we're doing, thinking about where the data we're working with has come from. How did that data get to us? What processes were there that led to us seeing this data in front of us? It's only through understanding that entire process, by having enough eyes on the data, enough people thinking about what's going on, that we're going to be able to ensure that data science lives up to its full potential, I suppose, that we really, do something good in the world with data science.
Thanks, Jess. Very well said. Joanna?
Thanks, Kate. I wanted to pick up on the discussion Flora mentioned around diversity and potentially thinking about how we improve the representation of women in the field, perhaps in some different ways. We know that as we look at the statistics, and obviously we're data analysts, so we do look at the statistics of women's representation in computer science, in cloud computing, in AI, in maths and stats, and it's low, right, hovering around 20%, and probably taken a backward step over the last year under COVID. But one of the things that I don't think as a community we do a great job at is describing the different types of applications of data science that might be more appealing to women without thinking about it being traditionally STEM disciplines. And so I want to use a personal example here, just as an example. My daughter went to film school. My daughter is a data scientist. She went to film school to get into the movie industry, and she's in the movie industry, but in fact, she's in the distribution side of the movie industry. And a lot of what she does day in, day out is data science, analyzing ticket sales, doing projections of where to release a movie in a particular region or a particular geography or a particular country, but she's actually involved in data science. But she would not really describe herself as a data scientist because she's really in the movie industry. And so if we think about the ways that we can think about attracting more young women in particular who are still in school into this data industry, we've got to look at the different role models and use cases to show how fascinating it can be. And it's not just about the perhaps more traditionally oriented science and engineering fields.
Joanna, would you say that it would hurt us or help us, particularly in your daughter's case, let's say, would it hurt us or help us for us to think of ourselves as a field? Like, does that make us a little bit too exclusionary and isolated so that she would then have to recognize herself as being part of the field? Or would it give her something to like leverage on?
I think it's around how do we ensure that the field of data science doesn't sound like it is exclusionary and male oriented because it's science. And we've really got to open up this notion of the opportunities to apply your experience into a variety of different domains: retail, business, fashion, medicine, the environment, climate change, things that matter, that enable us to demonstrate the investment in the fundamental technologies, enable us to look at things that matter.
Such an interesting perspective. Thanks, Joanna. Sally?
Yeah, so look, it's been really interesting listening to everybody's perspective on this. I mean, let me say, of course, we need more women in data science, and I want to actually put it out there that we're probably not doing as well as we should, and we've got a long way to go. So, Joanna talked about the 20%. I think in computer science it's 15%, but for some reason we're doing not so badly in maths and stats, quite frankly, so we're getting ahead of the game there. What I have learned, because we've been trying to recruit, is just how difficult it is to recruit in the computer sciences in women. While I agree that broadening it and having the applications as part of it, what really, really worries me is that if the future job growth is in those technical areas and we are not getting women across to those technical areas, are we shutting them out of future job growths? In order to be inclusionary and say, look, you don't have to worry about the technical side, we'll just be embracing in the sort of the application, if the future job growths are in that technical side, then what are we actually saying to the future employability of women? So while I think it's important to be embracing, I think we have got to do a better job of getting women across to the technical side. And I wish I had the answer, but I don't. I do think that it's a lot to do with mentorship. I do think it's about getting that critical, I love the 30 by 30. I think it's about getting some critical mass there together to begin with, but I think getting that critical mass is difficult. I've just been on a recruiting drive for Data 61, and we had 250 applications for the machine learning role, of which 17 were female. Now, had they said machine learning and statistics, I think we may have got a better representation. But so I don't know why statistics has done a better job, of why we are, but there is more women in statistics than computer science, and yet we're very, very similar fields. And one thing I agree totally with Kerry about, we are a field. It is emerging, and it is actually those intersections of computer science, maths, and stats doing research together that is the really exciting bit and driving the field forward. But yeah, I do think we need to do better. Yeah.
I mean, we have this opportunity, right? Given that we are a youngish field compared to maths and stats, which are, arguably fairly ancient, we don't have as much ingrained issues perhaps. So we have this opportunity to make the field what we want to make it. So, and I know, Sally, you said you don't have the answer, you wish you did, but does anyone here have some answers? Does anyone have any suggestions for our field for the first step, or the first small step, the first big step, or what we should be shooting for? Kerry?
Thanks, Kate. Great question. So I just wanted to say a couple of things in response to Sally's remark about statistics. I just want to applaud the work of the Australian Math Sciences Institute in their relentless promotion of statistics and maths as a profession, and a profession to get into. Also to Jess and the Statistical Society of Australia, that's been doing a great job in that field as well. So kudos to them. I also wanted to say that we failed, but we put in a bid for a Centre of Excellence for looking at the frontiers for data science, and we explicitly had a field of chief investigators that were all women. And we did that because we wanted to raise the profile of women. And how exciting was that? That was just so exciting to see across the country the women who are working from these different discipline areas that we talk about, but all coming together under the umbrella of data science. And, that didn't go forward, but I think there's momentum there that is really picking up around bringing together or making this community of women, in this case, our researchers, but making these communities are so important that we then feel like we have a home, we feel like we have somewhere to be. And I would advocate that that's really important, especially for the isolated people in different organizations. An organization, every organization wants a data scientist. And so that's probably why, Sally, you're finding it hard to recruit, because, people who are, people have a lot of options now. And okay, you've got 250 applications, and that's fantastic. But, there are lots of options, but many organizations are appointing, the data scientists to do the work on the data in their organization. And this poor person is dropped in to this sea of data and complications and everything from the engineering side through to the data management and governance through to the application side. And it's like, whew, how do they manage? So what they really need is this support, these floats. And I think if we think of these networks that we have, and as these floats that people can join and get some support is really important. And I'll make one other point too, that I think there's a lot of opportunity for second life careers in data science. Many of us, when we're at well, possibly not us, but people at school, like maths and stats and computer science, the technical subjects are not what really turns your lights on. But as you become, in your different areas and you grow in your profession, like Joanna explained, you get to understand that, yes, you do need these skills in analysing data. Data is so much a part of every organisation and every field. And so what I think we can do is really try to draw on that, that group of women who are wanting to retrain. You know, it's not just women, but I think we do have an opportunity to, you know, to capitalise on the second lives that people may want to have around data science.
Great points. Thanks, Kerry. Joanna?
Thanks. So a couple of points, right? To follow up on Kerry's point about retraining, I think there is a real opportunity here for women who have left the workforce, who want to re-enter the workforce and to come back in. Perhaps they've had kids, perhaps they've been looking after elderly parents, but re-entering the workforce and acquiring new skills. And what are our roles as educators to enable a flexible curriculum to enable people to pick up new skills in a very modular way, or new certifications in a very modular way, as opposed to having to go back and take a 4-year degree, as an example. I think there's another element as well, though, that says, and to Sally's point about fundamental skills, I do think there's an element of fundamental skills that's really important. And one of the things that really surprised me when I first moved to Australia is that mathematics is not compulsory up until year 12. And that's really surprising. In the United States, you have to do mathematics to graduate from high school. Many countries of the world require you to take mathematics all the way through school. So in terms of a policy change, then that seems an obvious one to me, but obviously there are many factors involved in getting kids to choose subjects within the school system, but fundamental groundwork in numeracy and digital literacy in the schools, I think, is going to be essential for us to be able to generate that workforce of the future.
Thank you, Joanna. Jess?
I wanted to talk a little bit about some of the things that are going on within the Statistical Society of Australia in order to try and increase the representation of women. But before I do, I want to mention that the Statistical Society of Australia is 60 years old this year. So we've been going on since 1962. Now, you mentioned, Kate, right at the start that Kerry Mengerson was the first woman to take the Pittman Medal for the Society. That happened in 2016. This hadn't happened earlier is really rather damning on the society, I feel. So when I came into a leadership role within the society, something that I'm really concerned about, really focused on, is ensuring that within the society, women are represented, gender diverse people are represented, people of different backgrounds are represented. So we've really got to focus on equity, diversity and inclusivity within the society. I think the society still has a long way to go on that, but I feel like we're really sort of getting there, ensuring that there are women in leadership roles within the society for people to look up to, ensuring that there are opportunities for women within the society. So something else I wanted to touch on was, Kerry mentioned that often you've got the lone data scientist within a company. And for statisticians, this happens quite a bit as well. For people who may not regard themselves as data scientists, who instead regard themselves as statisticians, you're often the lone statistician in a hospital or in some company, and you're tasked with taking on all of these things. How do you find a home? How do you find your community? It is really, really difficult to do so. And I think within the Statistical Society of Australia, we're trying to become the home for people who are interested in data, who want that community. I'd encourage you to check us all out. I've got to do a bit of a plug for the society here, statsoc.org.au. Come and see if there's something there for you. There are mentoring. We have a mentoring program for people who may want extra help in their careers. So that's something else that we do to try and encourage people. But I'll stop talking about the Statistical Society for a moment and let someone else take the microphone.
Thanks, Jess. Sally, did you have something you wanted to loop back around to?
Yeah, so just to the how might we sort of progress women forward, and listening to the comments that people made, and Joanna's and Kerry's, and in relation to Joanna's, and not making maths compulsory, I think which I think is, we probably should, but that's a bias that I have. But I think what's really difference in the genders at school is the level of exposure to, you know, computational techniques. If you look at the various graduating from high school with those type of skill sets, and those type of skill sets are every bit as important to data science. I mean, they're critical. Computational stats is well, it's computation, and I think we need to be getting in at a much, you know, like a 5 years old sort of level in order to change people's mindset if we're really going to shift that. So I suppose that's one thing. And the other thing that Kerry said, which I totally agree with, is we need at some point to have these rafts or these platforms that people feel that they are safe and can come to, where women feel particularly welcome. Without those, and it was a great idea of Kerry's putting up that Centre of Excellence, and without those sort of rafts, or with those rafts, I think we do have a hope. I mean, I do think that there's I don't know, I'll ask people, you know, is there room for positive discrimination? Should we actually go out and say we want X% of women by this, I mean, I know we've said 30 by 30, but how should we go about enforcing it? Should we just say it? Should we actually do it? I mean, say that, for example, what I'm trying to do at Data 61 is saying, you know, if we haven't interviewed X number of women, I'm not going to agree to any appointments that are going to go forward. So how do we achieve it? How do we actually go from where we are to where we want to be? Just actually asking the panel if they've got, you know, like when, you know, what their view of how much we should impose, you know, diversity measures and how stringently. Does anybody want to have
I'm a big fan of just putting a threshold and telling you can't hire anyone if you're not meeting the threshold, but no one puts me in charge of hiring. Kerry?
I'd just be interested to hear people's view on, I mean, it's what I'm facing at the moment, yeah. No?
Joanna, did you?
Yeah. So Sally, I mean, I think your instincts are completely right. If you're interviewing for a role and you have a slate of candidates that isn't diverse, by definition, you're not going to hire and improve your representation. But there are other techniques as well there, right? You've also got to ensure that the interview panels that you're putting together have diversity in the interview panels, so that you've got diversity of thought as you're evaluating candidates as well. But I think that's somewhat late downstream of being able to bring women into the field. And I think we also have to look at our university courses and university coursework and structure, the way that we think about putting student programs together, and some of the work that you're doing at Data 61 around student cohorts, because it is about, we've talked about gender diversity, but it is about diversity of thought. If you bring a business school student together with a mathematics student and put them on a project together, you'll get a very different experience and outcome from that project, because you've brought students together of different disciplines. So as we think about the education for the future, I think we've got to think about even rethinking the way education happens by bringing students from different faculties together, but working on projects around an environmental impact or a medical impact or climate change, for those of you who are sitting through floods at the moment, but bringing that discipline thought together, and our educators, bringing the faculties of education into this discussion around what does data science for the future mean. I think we've got to look beyond just the gender diversity, but the diversity of thought that includes the diversity of our educational systems.
Thanks, Joanna. Kerry?
Thanks, Kate. I agree with everything that's been said. I'd love to see quotas on jobs. I think it's really important that we promote that. I just want to put a caveat on it, though, is that what we need to be careful of is that we don't overwork the small proportion. Like, let's say there's 20% of women in a workplace, that they have to be on all the panels. You know, that when there's equal representation on panels, and when there's women who have to be in doing those kinds of jobs, that then you get very busy. That 20% of people get very busy. And so I just want to make a call out to all the people who are feeling that at the moment, that you know, it's a tough balance that we have at the moment. You know, we're walking that line, and that anybody who's in that position you're really waving the flag for women data scientists or women in the workforce generally, and we just have to hang in there until we get more of us in the seats.
Completely agree with you, Kerry, and I'll just double down on that and kind of say, although we think that there should be equal representation on these kind of thankless jobs like being on hiring panels in departments, we as women, as individual women in data science, are still allowed to make selfish decisions about our career and what is going to be rewarding to us career-wise or what we're interested in. We're also allowed to be individually selfish and not always feeling like we have to serve the community to build this forward. So it's a hard balancing act. So just moving slightly past who we are as a field and how we can raise that bar, I think one thing we've touched on a little bit here is this really broad range of applications that we can address with data science. And I suppose pivoting to think about the types of questions and applications that we address as data scientists, are we tackling the right problems? Should we be targeting more carefully our problems? How do we raise the bar in the types of questions that we're answering as data scientists and as a field? Flora?
Yeah, I really like this question because because data science is so interdisciplinary. I think there's a great chance for data science as a field to actually make a great impact, because that can start solving difficult questions that cannot be solved by just a single discipline alone. So, you mentioned climate change before, and that's absolutely, a field where there's lots of data, but also there are pockets of areas where there's not so much of great data. So we may have to rely on some specific technical expertise to look at how do we simulate, how do we actually generate data sets and things like that, right? How do we actually understand the fundamental problems in terms of the data science of climate change? So one field that I'm very, passionate about is we actually trying to promote a new subfield of data science called mobility data science. So so I was actually in a DASTOOL seminar in early January with about more than 40 top experts in the field, but actually coming from very different disciplines. Those experts in data management, to those in data privacy, to those in machine learning and AI, and to those who are expert in transport engineering, for example. Because, for example, mobility data science that has been tackled in different subfields in different areas, but we actually trying to solve similar problems. How do we understand how people move in cities, and how do we actually understand that better in order to, for example, plan, make better data decision-making, data-driven decision-making in, let's say, planning for cities, planning for infrastructure, even like electrification or sustainability of cities, or even like, if there's a disaster, like, what's happening now in the flood, how do we evacuate people? All of these can be tied into mobility data science. For example, pandemic management, where do we put lockdown, where do we constrain the lockdown? That's also to do mobility data science. So we're going to write a paper about this. But that is an example, just even what mobility data science, it can touch into so many different application areas. So there could be one example. So I'm thinking, like, for example, health data science, right? There's a lot of experts that can draw in, people from public health, people from biomed, people from, even the one that we mentioned about here, the fundamental computer science, stats by a statistician and all that, but can also bring in a lot of different expertise that actually deal with this data day in and day out. So I think we need to start thinking about the different verticals that we should target, especially with the big questions, big impact, and how do you actually then start turning the fundamentals that we've actually come up with into something that we can translate. So I think this is where we should go, and we can actually start bringing in people from different background and that different diversity background in industry and also research.
I love that. Thank you, Flora. Jess, what do you think about either the great things that Flora raised or our applications and directions as a field?
Look, I really do feel that at the heart of every application, there needs to be deep understanding of that application area. I strongly feel that as data scientists, as statisticians, we should be working very, very closely with the people who understand the data that we're generating. And I think this is what Flora was kind of saying in her response, that look, it's so important that we have this understanding of, and I said it before and I'll say it again, the causal pathway of our data. How did the data that we see here end up in front of us? Why did we see this data set and not some other data set? And I think it's absolutely important in any application that we have a deep understanding of the subject matter.
Thanks, Jess. Sally?
Yeah, look, in thinking about problems that we should work on, obviously, you know, we've all got our own views on what is a good problem or what is a societal good. And, you know, in Data 61, we have DARE, we have DASH, and we have DREAM. DASH is data analytics for societal health, and DREAM is data for engineering and data research in engineering and manufacturing. But it's just to bring this loop close between theory and methods and application, I want to sort of reinforce how much I believe that they're one. So I agree that we specifically do not need deep expertise in a particular domain area, but we certainly need to be working with somebody with specific expertise in a domain area. Absolutely. And I think actually getting those people, pi people, there's like the Greek letter pi with a leg in both camps that can do that translation is really important. But what I have found is that some of the best theory and methods that I've come up with has been in response to the application. So the two march in tandem together, and it is about tackling really difficult problems with people who are different in your totally different domain, that you actually come to realize why there is this new field, because you need all the traditional stuff in computer science, the traditional stuff in maths and stats, but it is actually working in the domain and answering a specific question that you then stand back and then are able to generalize across to other domains. And I think that that's what's really exciting about, and I think that's sort of what Jess was saying about needing the domain experts. There's no amount of data that's ever going to solve all these problems that, you know, like climate change or how we make society a more equitable place. No amount of data and wallowing in it by data scientists is ever going to solve that. You need to be working with the domain people. Yeah.
Thank you, Sally. Kerry?
I agree, but I also think I want to just touch on one thing. How exciting is it when you're working in one domain and then you go across to another domain that you actually really don't know a lot about, but then you bring the knowledge from this other domain into it. So how many new inspirations have been generated from that kind of activity where, you know, you look over the fence. And many organisations actually want that opportunity as well. They know that there's great things happening in another field, but they'd like to just be able to tap into that. And I think as data scientists, we have that great opportunity too. So I agree with you, Jess, that, you know, being deep in a field is really important, but then also being able to look over the fence, because they're the kinds of skill sets that we have. And Sally talked to that as well.
Yeah, about
Absolutely.
generalizability. Yeah. I like the idea of going from the specific to the general rather than the other way around, though. Yeah.
Well, unfortunately, we've run out of time, but I think I speak for all of the audience when I say this has been an incredibly inspirational and eye-opening discussion. I think we've cracked some problems here that I kind of didn't think that we were actually going to come up with answers to, and I think that that's fantastic. So just wholeheartedly thank you to all of the amazing panel for coming. I really appreciate it. It's been amazing. I'll remind everyone that you can see, you can rewatch or share this recorded presentation panel on australiandatascience.net, and that when we wake up tomorrow, it'll be Women in Data Science Day in the US and the rest of the world, and you can watch some of their live streamed events on widsconference.org. And thank you very much to everyone for coming. If you want to engage more with the Australian Data Science Network, you can do that through our website. Go there, sign up for the newsletters and really start engaging with this amazing network of people. Thank you very much, everyone.